Hey, so this is day 2 of learning Rome render, and today I dove a bit deeper into Clojure just to understand what Clojure is about. I set out a couple of targets for today, and then I ended up doing a bit different stuff, but still got some of my targets done. Overall, I wanted to build a table from a vector as well as from a map, and I wanted to see if I can add style to that vector, to the table, and then I wanted to see if I can get the block UID of the block running the Rome render component, and then the rest I didn't really get to, but I got to some other interesting stuff. So I set out with wanting to read a bit more about Clojure data structures, because that is really at the heart of understanding a language. So I found this resource. So this is the one, right, the first one here, if I can get this. Getting work done in Clojure, the building blocks. This is an excellent article with detailed explanations and demonstrations. I highly recommend reading this. What I learned from this is there are the primitive data types, and so these are the primitives. It is pretty straightforward. It's interesting that the character and the string is differentiated, and this is because Clojure runs on a Java virtual machine, and therefore it inherits Java semantics, where a string is an array of characters. But otherwise, nothing really surprising with the primitive data structures. And then, or primitive data types. And then I have, this is the key to, or one of the secret sauces as I read about Clojure, that data structures are immutable, meaning that you give them a value and you cannot change them. And then there are some ways around that you will see later. But in short, we have the vector, and you can see it's separated by spaces. And this is how I can define a vector with def function, and then from then on I can refer to my vector with its name. I can get the first element of the vector with get my vector 0. I can also conjugate my vector, add another element to it. The interesting bit is that this will return a new vector, which is going to be the vector including the fourth element, but still the original my vector will retain its original value of only 3 values. And there are two functions that you will use if you do recursive functions or processing, which I did today. The first function gets you the first element of the vector, and the rest gives you the remaining of the vector. Then there's the map, which equates to the dictionary in Python or the object in JavaScript. This is the format. What you need to know is there is no colon in between values, and a key can be a string or a number. So here's an example of a nested map. And then you can also use, instead of a string or a numeric key, you can also use keywords, and this is quite typical for Clojure maps. And so then you can get the value of a key using, again, the get function, and you can also associate, add another key to an existing map with the associate function, and you can dissociate, meaning you can remove a key with the disso function. Then you have the set, The difference between a set and a list is a set contains each value only once, and with set you can run the contains function and it will return true. With a list, contains doesn't work. And the list is a so-called what was it, lazy list or lazy variable, I don't remember. It's a different behavior in terms of execution when you use it. And then I went on and read about the difference between let and define. The difference is that when you define a variable, it's defined at the namespace level, and when you use let, then the variable is defined at the function level. So what are some of the things I did today? So I started out, I was very curious if I can do this. I started out trying to access some of the document properties of my underlying HTML document. I was using this document and this was quite helpful in explaining how to access the JavaScript document object. So one example here is getting the document's location. So you can see I get the href of the document, and the way this works is I call the JS document object, and when I'm asking for an attribute or reading an attribute, then I use dash attribute, and each attribute needs its own function call. So this is why calling document.location.href turns into this structure, but it works quite nicely. So you can see I got my location. The other bit I did today was getting the block ID. So if I come down here, that should actually give me the block ID. I can also prove to you that this is indeed the right block ID, but it isn't. Why is it not? That's an excellent question. I have no idea why it's not the block ID. It is definitely not the block ID. Frankly, I have no idea what's going on here. It's clearly not the block ID. Maybe it's a question of the active element. Now it's good. Indeed, because what it does, so you see now it's the right block ID. So what the script, so the trick here is it gets the block ID of the active element, and when I was refreshing it, I need to figure out, so there's a task for tomorrow how I refresh it. It wasn't the active block. My thinking is if I create a component and I insert the component, at the time of inserting the component it is going to be the active component, and therefore it will get the right block ID. The way this works is the same as in JavaScript. I go in and get the active element, the document active element.id attribute, and then I can also just show you the basic version. So you can see here the active element block ID looks like this, and then what I do is I just simply take the last 9 characters of that block ID. So I get the block ID of the actual block. Okay. Is this the right one? Again, not the right one. I really need to figure out what's going on indeed. And I think the idea I'm usually getting is the one above. Yes, indeed, because that's the active, and I call this, of course, this one. Yeah, so this is not yet um, not yet perfect. Anyway, so this is where I am in my learning process. And then I did a bit of building a table. So what I did here, I have two versions of building a table. First of all, I create a map with 4 key and value pairs, and then I go ahead, and this is a recursive function. What I do is I call the table with the sorted, so I use sequence to, I can show you the definition of sequence here. Here's my Clojure script. It should be here. Cheat sheet. Here. So the sequence function returns a sequence on the collection. So what it does is, if I feed it with a map, then it turns the map into a vector that I can then process. Objects. I'm just looking for where I read it, but trust me, yes, here you can see the example. Sequence can be used to turn a map into a list of vectors. So that's what I do with my map. I turn it into a list of vectors, and then I send it, or I call my table row function, which does a concatenate. The reason I need concatenate is because a Clojure function always returns its last call, and if I don't concatenate, then it will either only return this row, which, so I can show you what happens if I don't concatenate. So I'll remove concat from here and the closing bracket from here, and now if I run this, actually I get an error. Yes, because I need to remove these as well, I think. So now if I go and run this, what do I get? Oh yeah, I get nothing, because the last function call is the empty string. So actually what happens, so this is how I would get a value if I put it like this, because in the last, when I get to the end of the vector, then this actually stops. So this one is almost good. Now this is the only problem I have, and hopefully you see this now returns the very first key value pair, because then in each of the recursions it returns a value in the first line which is not returned or not concatenated. Therefore I need to concatenate, but when I concatenate, what concat does is it concatenates two vectors, and therefore I need to make this into a vector. Well, I can show you here the definition of concat, and you will see what it does, because it takes these two vectors and joins them, and that's why I need this additional bracket around my table row, such that when it's concatenated, this outer bracket or vector will disappear, and so I'll get my table. So this is the first one. You can also see that I was successful adding a style here to my table row or table cell. The other solution is just simply using a for cycle. So I loop through the table. This is more conventional, I would say. If you come from JavaScript or other programming languages, this might be more familiar. I create my table, and then for each row of my sequenced map, I create a new table row entry. So this is the more traditional setup. And one thing I didn't show you here is you can see I'm using the first and the rest functions in this. So that's what I mentioned earlier, looking at the vectors. And then finally, this was a very exciting and difficult part of the journey. I wanted to understand what namespaces and functions I have available in Roam Render. So I went ahead and did two functions. For one, I listed namespaces, and so what you can see here is I'm using the all-ns function from Clojure, and all-ns returns a sequence of all namespaces. And so what I do some formatting, because without this, I can show you this as well. Let me just and you can also see my earlier experiments up here, which didn't quite work. So this is, oh, and I need to uncomment this. So this is what it returns, and then I need to do this bit of formatting. Thank you, Internet, for the help on this. I found this, I don't know where exactly I found this pattern, and with that, and I actually did need that space. Oops. There we go. So my mistake, I did need that space, because that adds the new line in between each of the rows. Anyway, that's the function how I get all the namespaces, but more importantly, well, you can see my namespaces for playing right now, but other than that, you can actually see, if you disregard my namespaces, you can see the different available namespaces. And then if you're interested in what functions are available, then I've gone ahead and used, so this is a list of, I think, 500 items. I use the nsmap function, which lists a complete mapping of for the namespace with all dependencies, etc. And what I get here is a complete list of all the functions. So for example, I can see I have Q here. So this is a bit of a difficult piece, because for the Clojure namespaces you get the actual Clojure namespace, so that's great, and you know which functions are available in Roam Render. For these objects that are the Roam specific objects, these are JavaScript objects, and what I did here is I added this additional function. So if I have a specific function like Q, for example, that I want to check out, then I can add this row, and what this is going to do is it will bring up the function in console log. So if I now run this function again, so I come up to the top and I refresh this, and then hopefully, oh, and there it is. With that, I have, it might be a bit teeny tiny, I get my function here, and I can go in and read the function definition of that unknown object, and so I won't dive deep, but now with the developer tools in your browser, you can explore these functions as well. So far I haven't found a better approach. So that's pretty much where I got to. This one here is just an earlier version of the same. This only lists the functions without the objects or namespaces, and it's a slightly simpler script taking this namespace, taking the keys, sequencing it and sorting it and printing. So that was a pretty long day and a long video. I'm still very much learning Rome render, but I think I've made some good progress, and I'm quite confident that by the end of weekend I'll be able to create a component that produces a table of contents for any page I insert it to. So that's my target. Thank you.